Okay, so I'm pretty sure this is the first time that you guys have seen a hole in a graph. Is that right? Have you ever seen it? Okay, so a hole is going to look like this right here. So the graph is just going to be coming along, and then all of a sudden there's nothing, and then it continues on the other side. And sometimes with rational functions, that happens. And so we're going to talk about when that happens as we go through this paper. So yesterday, you guys learned about horizontal asymptotes and finding the y-intercept, and you also slant asymptotes. This one doesn't have a slant asymptote. So we wanted first to verify that the horizontal asymptote is where it's supposed to be. So we look at the degrees, and when the degrees are the same, like this situation, what do you do to find the horizontal asymptote? Good. Leading coefficient over leading coefficient. So 1 over 1 is going to be y equals 1. And when I look at the graph, there it is. That's a horizontal asymptote at y equals 1. So that's good. All right. And then for the y-intercept, how did we do that? Plug in 0. So we did g of 0. So that's going to give you negative 8 over negative 2, which is going to be the point 0, 4. And that's exactly where it is. So that's good. It checked out. Okay, then I wanted you to look at what's happening with the numbers. And so I have some values of the function here. There's an error when x is negative 1, and there's an error when x is 2. So let's talk about negative 1. So if you're looking at the graph, what's happening at negative 1? What is that? Yeah. So if you didn't know, I did draw an arrow from the word. So when x is negative 1, that's a vertical asymptote. All right. And what about when x is 2? That's where the hole is. So the function is going to be undefined every time there's a hole and every time there's a vertical asymptote. That value is just missing. There is nothing there. And we'll talk about why in just a second. Okay, and then the graph has one x-intercept. These can have more than one x-intercept, but this one only has one. And where is it? At negative 4. So negative 4, 0 right here. All right. So we're going to explore the features. So I wanted you guys to factor. And so I looked around. I think everybody I saw factored this correctly. All right. So now 5, the big question. I wanted you to find a relationship between the factors and the whole. So let's just start with that. I know the whole is when x is 2. When I look at my factors, I notice I have these two factors that 2 is significant because in those factors, when x is 2, you're going to get 0, which is actually going to create a situation where you have 0 over 0. That is what happens when there's a hole. But what we do with a hole most of the time is just identify it. And so what is significant about those two factors in the numerator and denominator? Now, I'm going to write it one way. You don't have to change it. If what you wrote makes sense to you, don't rewrite it. So I would say that they are common factors in the numerator and denominator. Okay. There is also a vertical asymptote when x is negative 1. So in this situation, I don't know what it is because I haven't actually plugged it in. But when you do, when there's a vertical asymptote, you get a situation like you get 5 over 0. So a number other than 0 over 0 is going to always be a vertical asymptote. But if we're looking at the factors, there's one factor that involves a 1, and it is this one. So the location of that is only in the denominator. Right. And then the x-intercept is negative 4. And I noticed that have a factor with a 4 in it, and it happens to be a factor only in the numerator. And maybe I should reword that because apparently it's confusing what I want you to do. I just wanted you to kind of figure it out on your own so you would remember it better. Okay, so we're going to get started on the notes, but we aren't going to finish them today. So we'll start them, we'll finish them tomorrow, and then you'll have a good portion of time tomorrow in class to work. This particular lesson I like for you to do in class, so I can help you when you get stuck. It's a lot to remember. Okay, so all the things we did yesterday, you could just look at the original equation or the original function and be able to find it. Today, the first thing we need to do to find the things we're doing today is to factor. So we're going to start off by factoring. So we're going to need to factor the numerator and the denominator. Okay, and then the domain is going to be, we're going to kick out anything that makes the denominator 0. So we want to find the domain before canceling the factors. Any common factors. All right, so as soon as you factor that denominator, look at the denominator and exclude any x values that are going to make the denominator 0. And those values are going to be the location of either vertical asymptotes or holes in the graph. All right, now a hole occurs when there is a common factor in the numerator and the denominator. And then these notes are extremely repetitive. Like this next statement, I say on every one of them, but that's okay. So we want to find the x value that makes these common factors 0. And that's typically, you can do that in your head real easily. Now, one thing we didn't do on that, the whole truth part, is find the y part of the whole. And so this is going to give you the x part of the whole. But if we want to find the y part, we're going to plug in the x into the reduced function after canceling the common factors. And that's pretty wordy. I'll show it to you. It makes more sense when you see it in an example than in just a bunch of words. Okay, then the vertical asymptote. The vertical asymptotes come from the factors that don't cancel in the denominator. Jeffrey, I forgot how to spell denominator. All right, I think that's right. All right, and then again, we want the x values that make these factors 0. Okay, and then finally, the x-intercepts come from the factors that don't cancel in the numerator. And we want to find the x values that make these factors 0. Okay, so we're going to do a whole problem. Well, actually, it's almost a whole problem. The only thing we're not going to do in this problem is draw the graph, which is one more thing we have to learn. But we're going to do all the things we did yesterday. So all of those things you can do without factoring. You can just look at it and tell. And so if we're going to do a horizontal asymptote, we're going to look at the degrees of the numerator and the denominator. They're the same. So we're going to do, you guys tell me, what are we going to do? The leading coefficient. So this is 1 over 1. So our horizontal asymptote is y equals 1. All right. Now, if there is a horizontal asymptote, could there possibly be a slant asymptote? No. All right. And then we're going to find the y-intercept. So what do we do? Good. So when we plug in 0, we get negative 16 over negative 4, or the point 0, 4. Okay, so that was all from yesterday. We can't forget that. We're going to build on that to do the stuff from today. All right, so all the stuff from today, we need to factor. So let's just go ahead and factor that. You guys do that on your own, please. All right, so as soon as we get that factored, we're going to look at that denominator. And anything that's going to make our denominator 0, we're going to say it's not in the domain. So what's not in the domain? Negative 4 and 1. So when we finish this problem, those should be the locations of holes or vertical asymptotes, because they are both undefined in your function, because they're places where the denominator would be 0. Okay, so which one of those numbers is going to be the hole in the graph? Negative 4, because that's the one that comes from the common factors in the numerator and denominator. Okay, so once we figure out that negative 4, we can actually just kind of cancel those. Now, one thing we didn't do before is figure out the y. So when we cancel that, it creates another function that is related. It is not the same function, but it's related, where I can take that negative 4 and I can plug it in for those x's. Now, I can't plug it into the original. The original is definitely going to give us 0 over 0, which doesn't tell us anything about the y part of the whole. But I can plug it into this one. So make both of those x's that haven't canceled out, make them equal to negative 4. And then it gives us a lot of time the whole is at a weird fraction. And that's okay. This is going to give us negative 8 over negative 5, or just 8/5. All right, so a hole is always going to be a point. All right. And a vertical asymptote is going to be a line. So when we give a vertical asymptote, it's the equation of a vertical line. And the equation of a vertical line is always x equals a number. So what would x equal for our vertical asymptote in this problem? It would be 1. Now, it has to be the other number that's not in the domain, or you can go back to the original. A factor that hasn't canceled yet, whatever makes it 0, is the location of the vertical asymptote. All right. And then an x-intercept is also a point. All right. So when we go to find the x-intercept, we're going to look in the numerator. We're going to look at a factor that's only in the numerator and it hasn't canceled. Whatever makes it 0, that's your x-intercept. So it's the point 4, 0. Okay, so that's all the things. There's lots of characteristics for rational functions. I'm going to go back to some of the ones from yesterday and just identify them as a line or a point. All right, so the horizontal asymptote is a line. So it's the equation of a horizontal line, so it's y equals a number. A slant asymptote is also a line, but it's a slanted line, so it'd be like y equals 2x plus 1 or y equals x minus 5 or something like that. And then the y-intercept is a point. Okay, so like I said, we're going to stop there today, and we'll pick back up and do a couple more examples tomorrow.